NASA's latest revelation has sent shockwaves through the scientific community and beyond. A colossal glowing red eye on Jupiter, unlike anything ever observed. Is this an extraordinary natural phenomenon, or does it hold secrets that challenge everything we know about the cosmos? Brace yourself for a discovery that could shatter our understanding of the universe and perhaps confirm the existence of alien life in our own solar system. The Great Red Spot is more than just a storm. It's a raging tempest unlike anything on Earth. This anticyclone, as scientists call it, used to be so massive that 3 Earth-sized planets could fit inside it. But over the years, it has been shrinking. According to observations from the Hubble Space Telescope, the storm now fits just over 1 Earth-sized planet. While its size has decreased, its intensity has not. The winds at the storm's edges have sped up by nearly 10% over the past decade. And if you think that's wild, consider this. It's also changed shape, shifting from an oval to a nearly perfect circle. Before we delve into this, it's clear that what NASA has uncovered is far more unsettling than anyone could have predicted. And this won't be the only discovery to leave you speechless. Despite its shrinking size, the Great Red Spot remains a beast of a storm. Observing it from Earth is no easy task, even with advanced telescopes. That's where NASA's Juno mission comes in. Launched in 2011 and reaching Jupiter 5 years later, Juno's mission is to uncover the planet's questions. For years now, it has been orbiting Jupiter, braving the planet's extreme radiation to collect invaluable data. And what Juno has uncovered about the Great Red Spot will make you see this storm in a whole new way. Juno's findings show that the Great Red Spot is not just a wide surface storm, but extends deep into Jupiter's atmosphere. How deep, you ask? Over 300 miles or 310 miles below the cloud tops. To put that into perspective, if a storm that deep were raging on Earth, its upper layers would reach as high as the International Space Station or beyond. This discovery changes everything we thought we knew about the storm. But how did Juno's team measure its depth? One method involved Juno's gravity science instrument. This high-tech tool measures gravitational changes caused by the storm. Think of it as detecting the fingerprint of the Great Red Spot on Jupiter's gravitational field. It turns out the storm's influence is measurable, despite being a mere blip in Jupiter's massive gravitational pull. These gravity readings revealed not only the storm's depth, but also its internal dynamics. The Great Red Spot is fed by powerful jets that extend even deeper, reaching depths of nearly 1,800 miles. That's deeper than anyone expected, and raises new questions about how such storms form and persist. But Juno didn't stop there. Another instrument on board, the microwave radiometer, provided a closer look at the storm's vertical structure. By probing the atmosphere with microwaves, scientists discovered that the Great Red Spot stretches far below the visible cloud tops. Beneath the surface, precipitation and strong vertical drafts create complex atmospheric layers. This finding suggests that Jupiter's upper atmosphere is intricately linked to deeper layers, making the planet's weather system far more complex than previously thought. Jupiter isn't just home to the Great Red Spot. The planet's atmosphere is a turbulent mix of cyclones, anticyclones, and iconic striped bands of clouds. These bands, separated by powerful east-west jet streams, create a mesmerizing pattern of white and reddish hues. Juno's data shows that these jet streams extend over 1,800 miles into the planet's atmosphere. Scientists are still trying to figure out how these winds form, but one clue lies in the movement of ammonia gas, which appears to align with the jet stream's paths. Cyclones and anticyclones on Jupiter behave differently than storms on Earth. Cyclones are warmer at the top and colder at the bottom, while anticyclones, like the Great Red Spot, are colder at the top but warmer below. This temperature difference adds another layer of complexity to Jupiter's already chaotic atmosphere. What's more, Juno's instruments have detected ammonia and water deep within these storms, hinting at unique precipitation processes happening far below the cloud tops. Juno's mission, extended until 2025, is far from over. While the spacecraft's current orbit takes it over Jupiter's north pole, it will continue to observe other fascinating features, like the planet's polar cyclones and its largest moons. These icy moons, known as the Galilean moons, could hold clues about the early solar system. By studying Jupiter, scientists hope to better understand how planets form and evolve. The Great Red Spot is more than just a storm. It's a window into the dynamics of our solar system's largest planet. Its depth, size, and changing behavior challenge our understanding of planetary weather systems. Thanks to Juno's daring mission, we now know that this iconic storm is even more complex and fascinating than we could have imagined. And as Juno continues its path, who knows what other things Jupiter might reveal? Beyond Jupiter, the solar system is full of amazing planets and objects, each with unique features that show how incredible our space neighborhood really is. The solar system is a wild, fascinating place, and there's so much about it that just blows your mind. It's a giant neighborhood full of wonders, from scorching planets to icy, distant worlds, and everything in between. Let's break it down and see why this vast space is worth all the attention. Skipping over Jupiter this time, that planet already gets enough love. The Sun, the king of our solar system, is seriously massive. It makes up over 99% of the solar system's total mass. That's right. Almost everything we see out there revolves around this giant ball of burning hydrogen and helium. Its gravity is so strong that it keeps all the planets, moons, comets, and even tiny space rocks in place, holding the whole system together like an invisible string. Without it, life on Earth wouldn't even be possible. Now let's talk about Mercury, the tiny planet closest to the Sun. You'd think being so close would fry it entirely, but here's the thing. Mercury has some of the wildest temperature swings ever. Daytime there can hit 430 degrees Celsius, but at night it drops to a freezing minus 180 degrees. And even though it's the smallest planet, Mercury's core is almost entirely iron, making it one of the densest objects out there. Venus, on the other hand, is Earth's so-called twin, but the similarities stop at size and shape. Venus has this bizarre backward spin, which means the sun rises in the west and sets in the east. It's also the hottest planet in the solar system, even though Mercury is closer to the sun. Why? Its thick atmosphere, loaded with carbon dioxide and sulfuric acid clouds, traps heat like a runaway greenhouse. Surface temperatures sit around 465 degrees Celsius, hot enough to melt lead. Earth, our home, is a gem of a planet. 71% of its surface is covered in water, and it's the only known place where life exists. Its atmosphere, packed with nitrogen and oxygen, not only lets us breathe, but also shields us from harmful solar radiation. No other planet in the solar system has this perfect balance. Not too hot, not too cold, making it just right for life. Then there's Mars, often called the Red Planet because of its iron-rich soil. This planet is like an adventure book waiting to be read. It has Olympus Mons, the tallest volcano in the solar system, standing a whopping 13 miles high. And don't forget Valles Marineris, a canyon system that stretches over 2,400 miles. Scientists believe Mars once had liquid water on its surface, sparking endless questions about whether it might have hosted life. Saturn is the superstar of our solar system when it comes to beauty. Its rings are what make it so iconic. They're made up of ice particles, rocky debris, and dust, extending over 174,000 miles, yet they're incredibly thin, sometimes only 33 feet thick. Saturn is also the lightest planet. Its density is so low it could float in water if there were a bathtub big enough to hold it. Uranus is the oddball in the family. It's tipped over on its side, spinning almost horizontally with an axial tilt of 98 degrees. This strange tilt causes crazy seasons. Each pole gets about 42 years of sunlight, followed by 42 years of darkness. And while its rings are faint, Uranus still manages to grab attention as an ice giant with a makeup of water, ammonia, and methane ices. Neptune, the farthest planet from the Sun, is like a wild wind machine. Winds there reach up to 1,300 miles per hour, the fastest in the solar system. Even though it's so far from the Sun, Neptune somehow radiates more than twice the energy it receives. It also has faint rings and 14 known moons, with Triton standing out as the largest. Triton's retrograde orbit suggests it was likely captured by Neptune's gravity a long time ago. It's not just planets that make the solar system interesting. Smaller worlds, icy regions, and ancient comets hold clues about how everything began. Pluto, though no longer officially a planet, still holds a special place in our hearts. Its surface has a heart-shaped glacier, and temperatures can plummet to minus 240 degrees Celsius. Pluto's orbit is quirky too, sometimes bringing it closer to the Sun than Neptune. Plus, its moon Charon is so big relative to Pluto that they're often considered a double dwarf planet system. Speaking of dwarf planets, Eris is another one worth mentioning. Slightly smaller than Pluto but heavier, Eris resides in a distant region called the Scattered Disk. With only one known moon, Dysnomia, Eris played a big role in the reclassification of Pluto back in 2006. The asteroid belt, sitting between Mars and Saturn, is like the solar system's leftover junkyard. It's full of rocky objects, with Ceres being the largest of them all. Ceres is so big it's considered a dwarf planet and makes up about 1/3 of the asteroid belt's total mass. At 584 miles across, Ceres even has icy patches and may hold clues about the early days of the solar system. Beyond Neptune, we've got the Kuiper belt, a vast region of icy bodies. It's similar to the asteroid belt but much bigger, stretching from 30 to 55 astronomical units away from the Sun. This area is home to dwarf planets like Haumea and Makemake, each with its own quirks. Haumea's fast spin gives it an elongated shape, while Makemake's reddish-brown color comes from methane ice on its surface. Comets, those icy wanderers, often steal the show when they pass close to the Sun. Halley's Comet is probably the most famous, showing up every 76 years. As comets heat up, they form glowing tails, making them some of the most stunning objects to watch in the night sky. They're like frozen time capsules from the solar system's early days. Farther out lies the Oort cloud, a theoretical zone packed with icy bodies. This region is believed to be the birthplace of long-period comets, stretching from 2,000 to 100,000 astronomical units from the Sun. While no one has seen it directly, scientists are pretty confident it's out there. The heliosphere is like the Sun's protective bubble, extending far beyond Pluto. It shields the planets from cosmic radiation, acting like a giant force field. The edge of this bubble, where solar winds meet interstellar space, is called the heliopause, marking the boundary of our solar system. Our solar system is just a tiny part of the Milky Way galaxy, located in a spiral arm known as the Orion Arm. It takes around 250 million years for the solar system to orbit the galaxy's center, a trip often called a cosmic year. That's a timeline that's hard to wrap your head around. Even the term planet has seen some changes. Back in 2006, scientists decided a planet had to orbit the Sun, be spherical, and clear its orbit of debris. That's why Pluto got demoted to a dwarf planet. It's all about the rules, apparently. Mars's Olympus Mons deserves another mention because it's just that impressive. At 13 miles high, it dwarfs Earth's Mount Everest, standing nearly 3 times as tall. It's a shield volcano formed by flowing lava, and its sheer size makes it a standout feature in the solar system. And how about Venus? This planet's day is longer than its year. It takes 243 Earth days to spin once on its axis, but only 225 days to orbit the Sun. That sluggish spin and thick atmosphere are why it's such a sizzling hot planet. The solar system is more than just planets and the Sun. It's a dynamic, ever-changing collection of objects that'll never stop surprising us. Whether it's the intense winds of Neptune or the icy comets of the Kuiper Belt, there's always something new to learn about our corner of the galaxy. Jupiter isn't just big. Its hidden layers, strong forces and strange moons show there's still so much we don't fully understand. Jupiter, the giant of our solar system, is like a massive cosmic problem that scientists still haven't solved. Sure, it's big, bright and famous for that giant red storm, but beneath all that, Jupiter hides questions that keep researchers scratching their heads. How did this colossal planet come to be? Did it form where it's sitting now, or did it wander in from another part of space? Figuring that out isn't just about Jupiter. It's about understanding how all the gas giants and planetary systems formed. One of the trickiest parts is figuring out Jupiter's internal structure. Scientists know it's mostly made of hydrogen and helium, and it doesn't have a solid surface. But what's going on inside? Is there a solid core hidden under all that gas? If there is, what's it made of and how big is it? Learning about its core could help us understand how planets this massive come together and what happens to matter under crushing pressure. Then there's Jupiter's atmosphere, a swirling mix of clouds, storms and colors that look like something out of a painting. Those famous bands and zones, the ones that wrap around the planet, are still not fully explained. What makes them form? And why do they stay so organized despite all the chaos? And those jet streams, what keeps them going? Plus, the colors in the clouds, from white and yellow to red and brown, are still a question. Scientists think it has to do with chemicals reacting to sunlight, but they're still piecing it all together. Jupiter's Great Red Spot is another head-scratcher. This massive storm has been raging for at least 350 years, maybe even longer. What's fueling it, and why hasn't it fizzled out like storms on Earth? It's shrinking, but no one knows if it'll disappear entirely or if it'll stick around for centuries more. And it's not just the red spot. Jupiter has other storms that come and go, each with its own quirks. Another standout feature is Jupiter's magnetic field. It's the strongest of any planet in our solar system. But why? Scientists think it's linked to the planet's rapid rotation and what's happening deep inside. Maybe it's the metallic hydrogen acting like a giant dynamo, but there are still gaps in the theory. Understanding this magnetic field is crucial because it affects not just Jupiter, but also its moons and the space around it. Speaking of moons, Jupiter's got a whole crew of them, over 80 in total, but the four big ones, Io, Europa, Ganymede and Callisto, are the stars of the show. Europa might have a massive ocean hidden beneath its icy crust. If that's true, could it harbor life? Scientists are dying to find out, and future missions are already planned to explore this possibility. Io, on the other hand, is like a volcanic fireworks display, the most geologically active place in the solar system. Ganymede is the largest moon, even bigger than Mercury, and it has its own magnetic field, which is rare for a moon. Then there's Callisto, which seems quieter but might have questions of its own beneath its cratered surface. Jupiter's faint ring system doesn't get as much attention as Saturn's, but it's still worth studying. What are these rings made of, and where did they come from? Are they leftover debris from shattered moons, or captured material from comets and asteroids? Understanding these rings can teach us about how similar systems work around other planets, both in our solar system and beyond. Jupiter's influence stretches far beyond its own orbit. Its massive gravity has likely shaped the paths of other planets and smaller objects in the solar system. Some scientists think Jupiter acted like a cosmic shield, deflecting comets and asteroids that might have otherwise hit Earth. But others suggest it might have sent some our way, contributing to mass extinctions and shaping life's evolution on our planet. It's a double-edged sword, and we're still trying to figure out just how much of an impact it's had. Then there are the questions of Jupiter's origins. Did it form where it is now, Or did it migrate from another part of the solar system? Some models suggest it could have started farther out and moved inward, disrupting other planets and objects along the way. This migration theory could explain a lot about the layout of our solar system, but it raises more questions than it answers. Even with all our space missions and telescopes, Jupiter keeps its answers well. The Juno spacecraft has been orbiting Jupiter since 2016, sending back incredible data. It's given us close-ups of the planet's poles, revealing strange swirling cyclones, unlike anything we've seen before. Juno's data is helping scientists refine their theories, but each discovery seems to uncover new questions too. The planet's extreme environment makes it a tough place to study. Its radiation belts are intense, and the pressures and temperatures in its atmosphere are off the charts. Any spacecraft that tries to get close has to be specially designed to survive these harsh conditions, which limits how much we can explore. Jupiter's questions aren't just academic. They have real implications for understanding our universe. Gas giants like Jupiter are common in other star systems, so learning about Jupiter can help us understand these distant worlds. It's like having a giant laboratory right in our cosmic backyard. Despite all we've learned, Jupiter remains a planet of questions. What lies beneath its thick clouds? How do its moons interact with the planet and each other? What role did Jupiter play in shaping our solar system? And what does it all mean for our understanding of planets beyond our own? Scientists will keep chasing these questions, sending missions and crunching data. Every answer we get about Jupiter brings us closer to understanding not just the planet itself, but the broader workings of the cosmos. And who knows, the next big discovery could change everything we thought we knew about our solar system. Could this giant red eye on Jupiter be a natural wonder? Or is it a sign of something more alarming, maybe even extraterrestrial? Tell us your thoughts and remember to like and subscribe for more.